Salutations, mini mathematicians! So happy you could join me again to talk about some volume of some polyhedrons, some shapes. And today, specifically, we're going to talk about the volume of a cone. And I'm not calling you a cone head. So we're going to derive the formula of volume of a cone from the volume of a cylinder. And specifically, we're going to look at cylinders that have the same base, like congruent bases, and they have the same height. So if you can see, these have the same height and they have the same base. What's different about a cone than a cylinder is a cylinder, I can slice this circle and just stack it height amount to make my cylinder. But a cone, if I start slicing this circle, those circles get tinier and tinier and tinier, but proportionally so. So we will be able to derive. So let's get started. And you will want a calculator today. Okay, so first thing we're going to do is we are going to test our drawing skills, and we're going to try and draw a cylinder and a cone that have the same height and the same base. So congruent bases, congruent like cookie cutters, exactly the same. So you could get some type of measuring device out to make sure they're the same, but sometimes what I like to think about is putting one inside the other so they have the same. So for example, if I have my cone, here's my cone, and then my cylinder is going to go just around my cone like so. So that's pretty good. Maybe I can make it look more 3D by adding some circles around it. So there is my cone inside a cylinder. So if we take a look at this cone inside the cylinder, which one has more volume? That's right. The cylinder has more volume. So how much more? If I took a cone of water and filled it up, how many cones would I need to fill the cylinder? How much does one cone fill? Do you think it's half of it? Do you think it's more than half? Do you think it's less than half? Well, lucky for you, you don't have to play with the water. I have a video for you. So here is, if you look at Desmos scientific calculator, if you need a calculator today, that's a great resource, but we're gonna watch this video. So notice what we have is these shapes that all have the same height. Here's our cylinder, and here's our cone. So these two shapes have the same height and they have congruent bases. So we're gonna take this nice blue water so we can see it. And when we fill up one cone and put in the cylinder, how much of the cylinder was filled with just one cone? Well, we'll mark it with an expo marker just so we can see. I think it's less than half though. So let's do this again. We'll fill up as close as we can. Whoop. And we'll mark that. Ooh. And we'll fill up, I bet one more can fit. Fill it up as well as we can, just a little more. Oh my goodness. It took 3 cones to fill a cylinder if they have the same height and congruent bases. Ah, really cool. So it took 3 cones to fill the cylinder up. And we'll look at the sphere next time. Okay, so how many cones of water were needed to fill the cylinder? 3 cones. So what fraction of the cylinder is filled by the volume of 1 cone? So if we put 1 cone in the cylinder, how much was filled? 1/3 of the cylinder. That kind of looks like 1/3, right? Maybe I can like split it like this, so maybe it looks more like 1/3. Okay, so how does the equation for the volume of a cone compare to the equation for the volume of a cylinder? Well, we know that 1/3 the volume of the cylinder is going to be equal to the volume of the cone. Let's use some of our substitution powers to figure out and derive the equation for the volume of a cone. Well, 1/3 the volume of any cylinder is the area of the base, which is pi r squared times the height. So we just found the volume of a cone, you guys. Any cone. So here's my cone. The volume is equal to, and we can call it pi r squared h all over 3, or you can think about it as volume is 1/3 times pi r squared h. And remember the visual we looked at, how the cone fills up 1/3 of the cylinder. Wonderful. Let's put this equation to work. So find the volume for each cone described below. Write your answer in terms of pi, your exact answer, and also as a decimal round to the nearest tenth, your approximate answer. And we're using 3.14 for pi, so hopefully you have your calculator or your online calculator ready to go. So taking a look here, of course, I'm going to start with the formula. So volume is equal to 1/3 pi r squared h. And it's important to write the formula while we're practicing. And that's a way we're going to memorize and put that formula into our long-term memory storage. So here, 1/3, I'm going to leave the pi there for now because we want to answer exactly in terms of pi. My radius here is 5. Notice it's just half being squared times the height of my whole cone is 8. It's a little bit harder to trick us about the height of a cone. Okay, so from here, 5 squared is 25. So we have 25 times 8 pi all over 3, which is exactly 25 times 8 is 200. So we have 200 thirds pi. And feet cubed. And here, if you put in 200 divided by 3 in your calculator, it's 66.6 repeating. So if you wanted to write that as a decimal, it is exactly 66.6 repeating pi feet cubed, which is approximately, we still need to multiply that by 3.14, and we get approximately 209. Here, if we do 66.6 times 3.14, 209.124. Since we're rounding to the nearest tenth, we will put 0.1 feet cubed. So again, we have our approximate and our exact answer. The next one we're going to do together is number 4. And remember, if I don't give you a picture, it behooves you to write one. So it has a diameter. Oh no, diameter monster. So we have our cone. That's a pretty good looking cone, if I do say so myself. And the diameter, they told us, was 9 meters, which tells me the radius is 4.5 meters. And they tell me the height is 4.2 meters. So again, to solve this, I'm going to start with the volume. Volume is equal to 1/3 pi r squared times height. So we're going to leave that pi there. So pi radius is 4.5 being squared times your height, which is 4.2. From here, we are going to multiply. So 4.5 squared, go ahead and grab your calculator. 4.5 squared, 20.25. Then we can multiply that by 4.2. And we'll get 85.05 pi. Oops, what did we forget, you guys? Yeah, we forgot to divide by 3 because it's 1/3 of all that. Okay, so 4.5 squared times 4.2 divided by 3, and we get exactly 28.35 pi cubic meters. And you might be saying, but Mrs. Barr, the directions said to round to the nearest tenth. Well, here I'm putting it to the hundredths because this is our exact answer, and that's where the decimal place ends at. And now we can do approximately times 3.14, 89 point, this is 0.19, so rounding this next door to the 0 is a 1, so it just becomes a 0 meters cubed. So there's our exact answer in terms of pi and our approximate answer. I'd like you to finish number 3. So go ahead, pause the video, finish number 3, show all your work, and we'll go over it as soon as you're ready. Okay, let's see how we did. So number 3, volume is pi r squared h divided by 3. Don't forget to divide by 3 like I almost did. Think about the reasonableness of your answer, and that's how you can catch yourself, forgot to divide by 3. So here we get exactly 2,000 pi cubic centimeters. I just want to check because I might have I used the pi button when I did this earlier, so it's going to be a little bit off. So this is approximately 6,280 centimeters cubed when we use our approximation. Awesome, great work there. Let's keep going. So our next shape is called a compound shape. So it's a compound shape because it's made of a cone and a cylinder. So the best part about this is you can think about this as the cone plus the cylinder. So taking a look here, some people might notice already that their heights and radii are equal. So you might notice that here we can say that this is pi r squared h divided by 3 plus pi r squared h. And this is only because their heights and their radii are equal to each other. So from here, we can say, you can work from here. So you could combine these if you wanted to. You can make this over 3 to add them and then simplify. I'm just going to go ahead and plug in the values and calculate away. So here, pi, our radius is 40 being squared times the height, which is 30, divided by 3. And over here, we're just going to have pi, our radius, which is 40 being squared times 30. And this way, I don't have to put as much into my calculator either. So 40 squared is 1,600 times 30. So this is 48,000 pi. And over here, we know that this will be 48,000 pi, but then divided by 3. So we're going to get 16,000 pi. So because these are both pi amounts, we can add them together, 16,000 plus 48,000, and we get 64,000. So this is exactly equal to 64,000 pi inches cubed, which is approximately, when we multiply that by 3.14, 200,960 inches cubed. So those are our two answers for this compound shape. Really nice job there. Remember, we always want to leave our answer in terms of pi until the end to be the most accurate with less rounding. Okay, number 6 says, if you have a cone with a volume of 188.5 cubic feet and a diameter, diameter monster, of 12 feet, what is the height of the cone? Show all your work. So when I'm taking a look at number 6, I'm going to draw a picture because I am a super visual mathematician. From here, I know the volume is 188.5 cubic feet or feet cubed, and I have a diameter of 12, which means I have a radius of 6 feet. Okay, and I don't know what the height is. Well, we have a couple of options. So from here, we could use our equation for the volume of a cone, which volume is pi r squared h divided by 3. And we can just solve for our height, meaning to get height by itself, I could multiply both sides by 3, and I would have 3v is equal to pi r squared h. And then from there, I could divide both sides by pi r squared because we are solving for h, and we would get the height, because that's what we're asking for, the height to be equal to 3 times the volume divided by pi r squared. So this is a great way to move around the variables without having to plug in big numbers and dealing with that in your calculator. So from here, height is equal to 3 times the volume, which is 188.5, divided by 3.14 times the radius, which is 6 being squared. Careful of your diameter, monster. So from here, I can just do parts of this in my calculator. I don't want to put all of this in my calculator at one time because the calculator does not do order of operations, and it's probably going to make a silly mistake. So you do you. Make your choices. 3 times 188.5, I get 565.5 divided by, I know 6 squared is 36, so I'm going to do 36 times 3.14. I get 113.04. From here, I'm going to, I guess this is an approximation because we have 3.14 already. I'm going to have 565.5 divided by 113.04. And we get, well, we get approximately 5.002. And remember, we are rounding to the nearest tenth for these word problems, so about 5.0. And we want to write our answer in a sentence, so we can say the height of the cone is about 5 feet tall. Notice it's just 5 feet, not 5 feet squared or 5 feet cubed, because we are dealing with one dimension, just height. Excellent. Okay, so the next directions for these word problems are giving us real-world situations that are going to make certain shapes. And since this was all about cones, I bet they're going to make some cone shapes. So let's take a look. Solve the problem and show your work. Use 3.14 for an approximation of pi. And round to the nearest tenth when needed. Write your answer always in a complete sentence. Directions are super important. Okay, so salt and sand mixtures are often used on icy roads, and the mixture is dumped from a truck into a staging area. And as it's dumped in, it forms a cone shape. So next time you're at the beach, if you take a clump of sand, just run it through your hands. It's going to create kind of like a mound, which ends up being a cone shape, kind of like this. And that's because of gravity. So cool. So from here, we are dumping this mixture from our cup, and it's going to make this cone-shaped mound, and it has a diameter. Diameter monster. These are like giant teeth around its like big mouth. Okay, diameter monster of 10 feet. And that means its radius is 5 feet. And it has a height of 6. And we want to know, what is the volume of the salt sand mixture? So how much salt sand mixture do we have? Do we have enough for the big snowstorm coming? Oh, are we prepared? So taking a look, of course, we're going to write the equation we're going to use because that's a big part of showing our work. So volume of a cone is 1/3 pi r squared h. If you like pi r squared h divided by 3, be my guest. So this is equal to 1/3 pi. R being squared is 5 squared, and the height is 6. So from here, right away, we can think of 1/3 of 6 is 2. So we have 2 times 25, which is 5 squared, times pi, which is 50 pi, which is approximately, this is where calculator comes in handy, 3.14 times 50, 157. So we have to write our answer in a nice sentence. The volume of the mixture is about, make sure you use the words about or approximately, 157 cubic feet. So we can say cubic feet or feet cubed, but there's our answer. Okay, so number 8, we're going to take a look at it. Notice it's asking about the greatest depth that the liquid can be poured into the glass. And if we read, it says a glass in the shape of a cone. So here's your glass. And you're like, how does it stay? Well, maybe it has like this little bottom thing like this, or maybe it's like this, and then it has like a stem, then it has like a little bottom thing. But anyways, it's a glass shaped like a cone. Maybe it's the inside of a mug and it's like super insulated, right? So your cold stuff stays cold and your hot stuff stays hot. But anyways, the liquid inside is shaped like a cone. And we have a diameter of 8 centimeters. Oh no, diameter monster. And the glass has a volume of 200 milliliters, and 1 cubic milliliter is equal to 1 cubic centimeter. So 200 milliliters is the same as 200 cubic centimeters, because you need to know that since our units need to match. So we want to know what's the greatest depth. So if we take a look at this, diameter is 8. Volume is, 8 centimeters. Volume is 200 cubic centimeters. And we want to know what's the greatest depth. So they are asking us for the height. Is there somewhere else we derived the height equation already? La-di-da-di-da, number 6. So go ahead and finish solving number 8 and let me know the greatest depth that I can fill in my beverage into this glass. Pause the video. Let me know when you're ready. Are you ready, kids? Aye, aye. So taking a look here, we have found that with this cone-shaped glass, the greatest depth that we can fit in here is about 11.9 centimeters. Awesome job, mini mathematicians. The more you know. Thanks for your hard work. Enjoy the rest of your day, and I will see you next time. Stay psyched, do your best, be nice to everyone, and make it the best day ever.